The alternative design, the one you probably would spend more time in your career working on, but it's good to know about both, is object-oriented design. So we're only going to touch on some quick ideas of object-oriented design across it. We're only going to be looking at a handful of diagrams that you're being asked to address in this class. And there is so much more that needs to be discussed at some point. There's entire classes on design that you can talk about. In your coding classes, you learn about Java or C++ or C Sharp, whatever. You'll learn more about object orientation. But at a high level, what we want to pull together here is the types of things based off the requirements, based off of the use cases that would be showing. And so the important things is classes and interactions. What are the different modeled things that you need to keep track of in your system, and how do those things interact to solve your behaviors? And so we're going to look through a lot of that as we go through these next several sessions. Now, the basics of class diagrams is you have a box, and the box represents a thing, and typically it's a thing drawn from the real world. So it could be a user, it could be a bank account, it could be a car that's being sold, it could be a car that's being insured, it could be a car that's being collected. The context matters in defining classes. And the context is defined by the attributes and behaviors that are put into those classes. So the top box there defines the name of the class. This middle box here defines the attributes, and normally there's a lower box here that includes behaviors that we'll get to later on. And also it's important to know that these classes don't act independently. There's lines that go back and forth between classes that show relationships. And depending on the type of line, they have different types of relationships. The most common being what's called an association, where basically I'm just saying I keep track of this other thing. So in this class, I'm the teacher. I've got a bunch of students who I keep track of, and you keep track of me as your teacher. And so I can send you notes, I can give you lecture materials, I can give you grades, but I know who's in my class. We don't just kind of coexist in the program. We have a direct connection. If you ask me who are your students, I can pull that list up and I can tell you. Same sort of thing with all classes that are coming along inside your object-oriented system. Now, the way we find classes is what we talked about when we did some of the analysis work earlier on. We look for nouns. We group them up inside of in interesting ways to look for classes. In design, though, we need to get more detailed. Just knowing the high-level data isn't enough. We need to start structuring it around how do we solve the problem. What other attributes do I need to know to write code, to keep track of screen colors and all sorts of other different things that are going to come up, configuration items, and which files do I write to, and which databases do I read from, and all that sort of stuff needs to start being added. So that's where our design starts to get different. We're not just looking at the shiny, happy analysis models that we talked about beforehand. We're also including the guts, the plumbing, to get those things coming off. So as we're looking for attributes, we want to make customizable objects that can be used in interesting ways throughout my system. We've got the nouns, we've figured out some more details about those nouns, and we want to start diving into how do I need to track data that lets my user know what's going on? So instead of just saying, hey, I've got a list of players, well, we might need to know an order of the players on your football team based off of maybe how you drafted them or how they've been shown the last time. Maybe in your order of your wish list from your sales site, you have a priority that is going to be shown on the display for which ones show up on top. Maybe you have a shopping cart based off of when you visited last time, but you forgot to log in, that I'm going to automatically add to your existing shopping cart when you do log in. Things like that. They're behavioral things that might not have been thought of right up front as technical requirements. So we need to then expand off the relationships. We know classes don't work alone, and we know that there's certain relationships that are added at the high level of the modeling that we saw, but we need to expand those relationships to include classes that help us control those interactions. So maybe we have, the customer who's going to go buy stuff, but we need to know there's a payment processor in between. So when they run their credit card, who's the one who actually runs this credit card? The requirements might not tell us. We need to figure that out. Who's our credit card processing company? When I go and receive a notice from the credit card company, how do I store that? I need an object that says whether it's accepted or declined and what the messages are and keeping that for later on. Well, that's the plumbing stuff we need to define and the relationships that live within the rest of the solution we have. And so some of those relationships shows up as associations like we talk about. We just keep track of each other. Some of them could be keeping track of data to call later on. Some of them could be parameters passed back and forth to each other as they're calling methods. But they could also be inheritance, where one class extends out the behavior of another class, or we could be grouping things together so they can be interchangeably used in features down the line. We could have interfaces that fall into this as well. There's a lot of different relationships that, again, if you want to know about this stuff, there's plenty of classes that help drive into these details. But I want you to be aware of this so you can use them appropriately as you're considering your design. And then finally we get to the methods, the behavior that's going on. This is what we get starting with what's happening in the use case. But the difference in use cases is we're not breaking that down through functional decomposition. That's what we talked about in the structured design part of it. Go look at that if you haven't done it already. What we need to break down is which objects participate in a use case and what is each of their roles inside of there. It might not be clear. It might not be apparent that an object has a role in a use case. It might not be a primary driver, but it could have some behavior that's shared across a number of use cases that it helps contribute. Hey, I keep the config data, so what's the font size that the user prefers when they visit our website? That might not be completely apparent from the use case, but it's something that might be contributing to every use case. Every time the user visits, we set their screen size, their screen color, everything else based off of something we've stored. So our design needs to look under the hood. In analysis, we focus on the business objects, what relationships, but we need to see details of making our system work. We've kind of been introducing that idea. Let's dive into that a little bit further. Let's make sure we understand the types of classes that we'd be expecting to see. Because we need to pick for every feature a worker. We don't just have figureheads up front sitting there saying, hey, elect me. For every politician that's out there, there's dozens, if not hundreds of staff members who are off making things happen. You're really less electing a person than you are a whole organization that's going on inside of there. All the people who support them, all the people who work for them, who are actually reading the legislation, everything else like that. That's exactly the same sort of thing we have in our system. We have a lot of objects that are implementing the plumbing that enables the business model. They're talking to databases. They're logging to files. They're storing sessions for when users come back and forth. And we generally want to separate out the cool business stuff versus the technology stuff that's a necessary evil. We do that using frameworks and error handling and input-output and all those sorts of things, but we don't want that to get tied into selling stuff and trading football players and buying insurance and all the different things that we would be normally doing in our systems, because technology changes over time. I want my business to outlast any individual technology. I want to be able to swap out, the old crusty web pages and throw in new phone applications, which seems to be what everybody's doing these days. And then I want to get rid of those crusty phone applications and move to the embedded chip in your brain applications or whatever's coming next down the road. And so we want to create structures that organize our code to allow us to separate this out. Now, typically, we're going to do something along this lines. We're going to have the basic business objects. This item class right here is something you might be buying or something you might be storing or something you might be selling or something like that. And then we have a bunch, for this one class, we have a graphical user interface element. Maybe it could be a Swing application, it could be a phone application, it could be a website. And then there's some controller that allows us to do things to items. We can item, we can update them, we can create them, we can validate them, we can delete them, we can sell them, we can buy them. The controller is the one that facilitates all this work happening behind the scenes. And it works with the item, it works with the owner, it works with the bank, it works with the processing company, with the credit card, it works with the seller, it works with all this sort of stuff, and something called the data access object, which facilitates all the stuff that's happening within databases. It facilitates all the stuff that's happening behind the scenes that I might not be seeing otherwise. That's really important towards the work. So the design elements we need to consider then, and we're just giving an example of this, but we need to consider what are the data objects. That's the business objects we talked about. how do I display this, and what code am I going to have to write to display this stuff? Is it web pages? Is it Android applications, iPhone applications, Swing applications, user interfaces, Microsoft Foundation classes, whatever it's going to be? How do I control all this stuff? How do I access data, and what are the helpers that are out there? And patterns can help us break this down. We don't have time to get into much details, but there's these things called design patterns, and they separate classes based off of the roles. Classes that do interface stuff, whether it's web services or user interfaces. Classes that do database stuff. Classes that do business logics. Classes that bind all this stuff together and have it work. And so the one I've been showing you is called the Model View Controller class. This basically says I have a model, which is your business and data logic over here. I have a user interface, a view that's up here. I have a controller that's down here. And then to the side, part of kind of the plumbing, the helper, is this talking to the database or talking to the files or talking wherever it's stored. So this is the high level of what we're trying to capture just from a static context. We're just trying to say, what are the pieces, what are the classes, the code I'm going to write, the files really of that's going to happen here. It's not telling any story of how do I do this behavior, how do I realize this behavior. It's only telling the story of what are the pieces that I'm about to build. We're going to get to the behavior side of it next. That's going to be the next thing we're going to talk about. But very separately, we can start to model these things out because they're going to be based off of standard concepts that I have. I mean, you're going to build a car. You have tires. You have a steering wheel. You have a brakes. You have a transmission. You have an engine. You have pieces on your engine. I don't necessarily know exactly how they're going to work together. Maybe my engine's hybrid. Maybe it's electric. Maybe it's something else. But I know the piece is going to be there, so I can start to assemble it and then tell the rest of the story separate on. I put them together that way, and that's what we're going to do next. So try and see what pieces you can come up with, and then move into the exact behavior that you're expecting to see. And that'll come next.